Hello viewers, welcome to Mobilemaths with Gamtran. So today I want us to look at paper 2 June 2020 session. So here we have got section A and section B. So our section A has 52 marks and we must try as much as possible to get all those 52 marks. Let's go to number 1. Our number 1 is saying that the difference between two fractions is 3 and 2/3. Then we are given that the smaller fraction is 2 and 1/4. So what it means here is this. We are saying if we have this bigger fraction, let's say the bigger fraction is going to be an x. Okay, so let's say the bigger fraction is x. So this is our bigger fraction, is x over 1, like that. Okay, so we want to find this fraction there. And we are saying bigger fraction minus smaller is equal to 3 and 2/3. Okay, so what it basically means is that for us to get the bigger fraction, we can simply say our bigger fraction is equal to 3 and 2/3 plus our smaller fraction, which is 2 and 1/4. So basically, this is how we are going to get this bigger fraction there. This was hypothetical. Now let's find the bigger fraction. So it's now a matter of here, multiplying here and adding, multiplying and adding. So when we do that, we will get 3 times 3, we get 9 plus 2, that will be 11/3. Plus, if we say now 2 times 4, we get 8 plus 1, we get 9/4. We must now have a common denominator, a number that 3 and 4 can get into. That will be a 12. So we can say it's all going to be over 12. 3 into 12, we get a 4. So it's going to be 4 times 11. Then plus 9, 4 into 12 there. That will be a 3, so it's going to be 9 times 3, like that. Okay, now let's simplify this expression. 11 times 4, we get 44, so this is going to be a 44. 44 plus 9 times 3, we get a 27. All is over 12, like that. Okay, so if we add 27 plus 44, we get 71, so it's going to be 71/12. Okay, so we can divide the 71 divided by 12, we will get a 5. Okay, so here I'm getting a 5, and then this is going to be a 5, and we get a remainder of 5 there. 12 by 5, that's 60, so we get a remainder of 11/12 there. So this is our final answer there. So this is the bigger fraction. Even if you want to redo it, you can even have a proof and say 5, then here you multiply and here you add. So you simply get 71/12, then you say minus the 9/4 there, the 9/4. So it will be like 71/12 minus 9/4 there, and you get a same common denominator, which is 12 there. So you have 71 minus 4 into 12 there, that's 3 times 9, you get yourself 27 there. 71 minus 27, you are getting the 11/3 there. Okay, so that's basically how we do it and how we prove that we have done the correct thing. Let's move on to the next question. The next question is saying the population of a certain country is 24.9 million. Then they are saying express this in standard form. So basically, we have to convert this from 24.9 million into a digit number. So we are just multiplying this number by a million. Million has got 6 zeros, like that. So we'll get 24, 9, and our 6 zeros, 1, 2. So they are now like, because of this 9 comma, they are going to be 5 now. Okay, like that. So this is 24 million there. Then to write in standard form, remember we said our standard form is A times 10 to the power of n. N will be a number from 1 to 9. Okay, we cannot have 24. We should have at least a 2. So I start here. When I don't have a comma like this, I start from this point and I'll count 1, 2, 3, 4, 5, 6, 7. So my n there is going to be plus 7. Then my a is going to be 2, like that. So my final answer will be 2.49 times 10 to the power of 7, like that. Okay, let's go to the next number. The next number, we are saying increase $40 in the ratio 8:5. Okay, so basically the simplest way, we are just saying $40 times 8/5. That's basically what we are doing. That will be the ratio 8:5. It's 8/5. So if you multiply this one, 5 there goes there, 5 into 40 there, 40 divided by 5. If we say 40 divided by 5, we get 8. So it will be 8 times 8. $8 times 8, we get $64. So we can write $64 like that, the same way they have written for us. Okay, let's go to the next question. The next question is saying evaluate that. Okay, so we can rewrite this in the term like this. The squared part here, we can say it's the same as 7 is squared. Then we also multiply by square root of 5 is also squared, like that. This is the same expression. And we should always take note that when we square a square root, it's the same thing as removing the square root, because square root is the same as a number to the power of half. Then when you square it, you are now multiplying to the power of 2/1. So these 2's and 1's will cancel off each other and you remain with a number like that. So when you have like 5, square root 5 times square root of 5, you get a number which is 5, like that. Okay, so let's write our answer. So we are saying 7 squared, we get 49 times square root of 5 times square root of 5, which we said this will give us a 5. Okay, so it will be 49 times 5, and we will get our answer. If we multiply 49 by 5, we get 245 there. Okay, like that. That's our answer. Let's move on. Okay, we are now on number basis. They are saying add 1, 1, 0, 1, 1, 2. It's base 2. This one is in base 2 and this one is in base 5. So what you do when you have such a question, and remember the answer is saying in base 5. So it is easy for us to convert this number here to base 5. Then we add them together. The process of changing that base 2 to base 5, you go via base 10 first. Then from base 10, you go to base 5. Okay, so here is how we go to base 10. We say 1, 1, 0, 1, 1, base 2. You raise the base to the power of 2 to the power of 0 here, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4, like that. So this is going to be equal. We are expanding 1 times 2 to the power of 4 plus 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus lastly 1 times 2 to the power of 0, like that. So when we add here, 2 to the power of 4 is the same as 2 times 2 times 2 times 2, 4 times. You get a 16 plus 2 to the power of 3, that's an 8, plus a 0 here. Any number multiplied by a 0, you get a 0, plus a 2, plus a 1. So if we add all of these numbers, we are going to get 27 base 10. Okay, so for this question, the space they provided was very small because we have just done one step. And now we want to convert this base 10 to base 2. Let's convert that number. I'm going to rub off this and we convert 27 base 10 to base 2. You are going to simply divide. We simply do what I normally call long division. So we have our 27 there and our base 10 here. We want to go to base 2, we are going to divide by 2. To base 5. So we are going to divide by 5. 5 into 27, it goes into 25, 5, and the remainder 2. 5 into 5, 1, remainder is 0. 5 into 1, that's a 0, remainder 1. Then you take your number from the bottom going up. So our number, this whole number going to base 5 is now 1, 0, 2, base 5. Now we can add this number and this number here. Okay, let's add them together. We are going to say 2, 4, 3, base 5 plus 1, 0, 2, base 5. Let's add. 3 plus 2, we get a 5. And I'll say we have a 5 and our base is 5. Me, I normally subtract 5 minus 5, I get a 0. Then because I have 1, so I can say plus 1 here, the whole number that I have. Others, they can say 5 divided by 5, we say it's 1, remainder 0. Okay, then you write your remainder here, and then your 1 there, you carry it down. It's one and the same thing. You do what is easy for you. Then I'm saying 4 plus 0, we get 4. Plus a 1 that we have carried, we get another 5. 5 divided by 5, you get 1, remainder 0. We write our remainder 0 there, we carry our 1. 2 plus 1, we get 3 plus 1, that will be a 4. So our answer is going to be 4 in base 5. Okay, like that. That's how we answer this question. Let's move on to number 2. Let's look at question number 2. Okay, so number 2 is saying here we have got 2 similar cups that have got diameters 6 centimeters. So we have got a cup here and another cup there. Their diameter, the other one is 6 and the other one is 10, like that. So they are saying write down the ratio of their volumes. So to get the volume of these 2 cups, we can say we have to find the for the volume, we can say using the radius. Remember, we calculate our area using radius. So we can say half of 6 is going to be 3, half of 10 there is going to be 5. So in terms of their ratios, it's going to be 3:5. So the volume is cubed. So we can say 3 cubed to 5 cubed, like that. Okay, so you find out when you say 3 cubed there, we are going to get 3 times 3 times 3, we get 27. So this is going to be 27 to 5 times 5 times 5, we get 125. So this is the ratio of the volumes. If they had asked us for the ratio of the areas, we're going to say 3 squared to 5 squared, and we'll get our 9 to 25. This is for the areas. So that's how you do such questions. Let's move on to the next question. So it's now saying that we are given that the volume of the smaller cup is 100 cubic centimeters. What is the volume of the larger cup? So basically here we are using the ratio. We said the volume ratio is 27 to 125, like that. Okay, so when we have it like that, we also use our ratio that we are given. For the smaller, they said it's 100 cubic centimeters. As to how much here, for the larger, it's going to be more. So when it's more, you put the more on top over the less there. So at the end of the day, I'm going to say it's going to be our more here is going to be the volume for the large cup. Volume for the large cup is going to be equal to 100 times 125 over 27, like that. Okay, so that's how we are getting. We are cross multiplying here and we are dividing there by 27. So if we do that, 100 times 125, we get 125 times 100, we get 12,500, divided by 27, that would be like 462 let's say 0.9 here, 96 centimeter cubed. Okay, so this is the volume for the larger cup there. Okay, let's move on to the next question. Okay, so here we are asked to calculate, okay, saying a wooden block is in the form of a prism whose cross-sectional area is a parallelogram with a base 35 centimeters, perpendicular height 20 centimeters, and length 1.2 meters. Okay, so the best way to answer this is to first of all draw a sketch diagram. So my sketch diagram is going to be like this. This is a parallelogram. Okay, this side is parallel to this one. Okay, like that. Then this side is parallel to this other one here. Okay, like this. Then we are given the base is 35, so we can say this is 35 centimeters. Then the perpendicular height, which is this external, which is at 90 degrees here, is 20 centimeters. Okay, then we are also given the length, meaning to say this side is going down there like that for about 1.2 meters. Okay, so I will remove this other part and just use this side here. Okay, so it's going to be going this side by 1.2 meters there. And we can convert this to, if we want, to centimeters. We'll do that later on. Now let's use this information that we have. Calculate the surface area of the cross-section of the block. So basically we want the area of this face here that we are seeing now. Area of a parallelogram, you can divide this into half and you have triangle A, triangle B. Okay, and our area for a triangle is half base times height. Then since there are two, A and B, we can multiply here by a 2, like that. So it is going to be 2 and 2, they cancel off each other. So the area of a parallelogram at the end of the day will be base times our perpendicular height. So our base is 35 centimeter by our perpendicular height 20, and if we multiply we get 700 centimeter squared, like that. That's the cross-sectional area of the face. Let's move on to the next question. Okay, now it's asking us about the volume of the block. So the volume is the face by the length there that is going there, which is 1.2 meters. And we said we can convert this 1.2 meters to centimeters. This will be 120. This will be 120 centimeters. Okay. Now, a volume of the block is simply equal to cross-sectional area times our height or our length. Okay, so we can say our height, our length. Let's use length here. Okay, so it is going to be 700 times 120. So when we multiply this, we'll get 84,000 cubic centimeters, like that. This is the volume. Let's move on to the next question. Okay, we are now given that the mass of the block is 3 cubic centimeter. So they're saying the mass of the block, if 3 cubic centimeter weighs this, what about our 84,000? So basically this is ratio 3 cubic centimeters as to 2.5 grams. Then 84,000 cubic centimeter as to how many grams? Okay, so it's going to be more. So we say when we do our cross multiplication, since it's going to be more here, it's going to be more. We have 84,000 on the top there over 3 times 2.5 there. Okay, then we multiply. So if you multiply here, we'll get 7 70,000 grams. So you can write 70,000 grams since they have used grams there. If you want, you can convert this to kg. You divide by 1,000, that will be 70 kgs. Okay, it's still the same. This one and this one are okay. Let's move on to number 3. Number 3 is saying find the value of y when we have such a scenario here. So we have two matrices that are multiplying each other. First of all, I always advise you to check if they can be multiplied together. So we say this first one is a 1 by 2 matrix. The second one is a 2 by 1 matrix. What it simply means is that there is a 2 and a 2, so you can multiply. Then the 1 and the 1 there is showing that the final answer is a 1 by 1 matrix, which is this one. Okay, so now let's multiply. Multiplying, we say row by column. So I'm going to have y times minus 2, then plus 4 by 3 is going to be equal to this answer there, minus 2, like that. If you want, you can maintain the brackets to show that it is a matrix. These ones, it's still okay, or else you can use it as an equation. It's all still okay because we want to find the value of y. So here I'll have minus 2y plus 12 here is equal to minus 2. Okay. Then if I take this one this side and this one this side, I'll have 12 plus 2 is equal to 2y. So it's going to be 14 is equals to 2y. Dividing by 2 both sides, I get my y as 7. So our y value there is a 7. Okay, let's move on to the next question. Okay, this one is saying find the matrix P such that P multiplying that matrix is equal to this matrix is an identity matrix. This is an identity matrix. Okay. So what it means is this. The P that we are multiplying is basically the inverse of that. Because when we have, let's say, an A matrix times an inverse there, we get an identity matrix I. So basically what we are looking for is the inverse of this one. So let's look for the inverse of that matrix. Okay, the inverse is going to be, we find the determinant. The determinant first is equal to, we cross multiply these ones, 3 by 0 minus these ones, 2 minus 2. Let me write it properly here. Minus 2 by minus 4. Okay, so we're getting a 0 minus 8. So we get an 8 here. That's our determinant. Then our matrix is going to be, our inverse matrix P is going to be equal to 1 over determinant, which is 8. Then we now go to our matrix. Okay. We interchange 3 and 0 there, so it's going to be 0 and 3. Then we multiply these ones with negative values. So negative 1, so it's going to be here a 4 and here a minus 2. So this will be our value of our P matrix. Now they are saying the equation of a line is y plus 3x, which is equal to minus 4. Find the coordinates of the points where the line crosses the y-axis. Okay, basically, if I'm to draw, let me just draw here. If I'm to draw the scenario, it's going to be something like this. This is the y, and this is my x here. Okay, when it crosses the x-axis, we have a y value. We have got an x value there. Let me write it properly. I've got 0 and a y. Okay. Then when it crosses the y-axis, I've got a 0 and a y value there. Okay, so this was an, let me check something. Our x is 0. Our y is, okay, for the first one there, that was this one. When our x, we have an x value, so I can say x and a 0 here, like that. Okay. That is now correct, because when we write our coordinates in this, it's in the form of x and y, like that. Okay, Fine. So when it's crossing the axis like that, it is going to be 0. So they are asking us to write the coordinates of the points where the line crosses the y-axis. Okay, so what we can say is this: we have our equation y plus 3x is equal to minus 4. Okay, now we can substitute. Let me write it in the form of y. So this is going to be y is equals to minus 4 minus 3x, like that. We normally write it y is equals to minus 3x minus 4 in the form of y is equals to mx plus c. Okay, fine. Now we know the values of the x's and the y's, these ones, because that is where it is crossing the y-axis, this one. So our x value, this is our x and this is our y. Our x value is 0. So we can find the y value there. Okay. So we can say our y is equal to minus 3. Our x is 0 minus 4. So our y is equal to a minus 4 there, like that. So it means the coordinate of 4 here is 4. Okay, of y is 4. So it is crossing at 0 minus 4, like that. Okay. So we can say 0 minus 4, like that. Let's move on to the next question. Okay, now they are asking us to find the gradient. The question is asking us to find the gradient of the line. Basically, our equation was saying it's y is equal to minus 3x minus a 4. Okay, like that. So when it's like this, we have a general equation of line which is equals to y is equals to mx plus a c, whereby our m is our gradient, our c is our y-intercept. Okay, y-intercept where the line crosses the y-axis. Okay, so the gradient basically on this one is going to be minus 3. Okay, let's move on to the next one. The next question is saying equation of a line is parallel to the line y. Okay, so we have got two lines that are going to be parallel to each other like this. Okay, and they have the same gradient. Okay, so they are saying it's passing through a point 3, 5. Okay, so we want to find the equation of that line. That's the question. So what we know is that they have the same gradient. Our m is minus 3. So we have to find the y-intercept. We are going to use the same equation. Y is equal to minus 3x plus a c. We want to find the value of c there. Same gradient, minus 3 there. We want to find. So the points that we are going to use are 3 and 5. And remember, this is our x and this is our y. So our y is 5 is equal to minus 3. We are substituting times our 3 plus our c. So if I multiply, I get 5 is equals to minus 9 plus a c there. Then I take this side, it becomes a 14. So our c is a 14. That's where our line is crossing the y-axis. Then in terms of our equation in the form of y is equals to mx plus c, we have our equation as y is equals to minus 3x plus a 14, like that. This is the equation of the other line which is parallel. Okay. Now we are looking at construction. Okay, so let's do our construction on this page. Let me just open the question. Construct. So whenever we have such question, it is good to just have a sketch of the diagram. We want to draw a triangle ABC, and so normally use the angle first, and then you derive the other points from that. So we have got A, BAC, so it's at A, so I can say this is my A, and I want to construct my 40 here, 45 degrees there, like that. Okay, so I have my 45 at this point, and then I'm going to A, B, and C. So I can go to B here, and then I can go to C. Then the distances are going to be A to B, 7, and then A to C is A to C we are not given, but we are given for B to C. So it was easier for me to say this is my C here. Let me interchange this. This is my C and this is my B, so that I have my 7 here. Then from my B, I'm given BC is 7, then I can find that point there. Okay, fine, like that. So this is more like the sketch that we can have. Now let's draw the triangle together on the space that is provided. Okay, so drawing our triangle, first of all, we draw our straight line, we mark a point, and we name it A. Okay, then we draw 45 degrees, we open our compass and we measure those points there, then we mark and we mark there. If you want, you can go to the bottom, but these 2 points are enough to give you a 45 degrees. So we get our 45 from a 90 degrees. Then from here, we are now going to bisect this 45 degrees there, and we get these points. We are bisecting the 90 degrees to get our 45 degrees. So this is our 45 degrees there, even if you don't write it. Okay, we are done with that. Then we are given that the distance from A to B is 7. So we measure, we get our 7 there, 7 centimeters. So this is our B. Then we are given BC is 8 centimeters. So you are going to measure 8 centimeters. Then you mark from point B. Then you find out it is going to cross at that point. Okay, so when it's crossing at that point, then you now join these 2 points there. Okay, this was not straight enough. Okay, so this is our C at the end of the day. We have constructed the triangle ABC with our 45 degrees. Let's go to the question. They are now saying the locus of points equidistant from B and C. Okay, so when they give you 2 points, it means we are bisecting B and C. Let's bisect our B and C there. Okay, so if we are to bisect, you come from this point, you open, okay, then you go to this other side. Okay, you go to B, you open again, like that. Then you draw a line that will pass through the points that you have, like that. So the distance from this point to here should be equal to the distance from here to there. Okay, when you do it properly. Okay, I'm just sketching so that we have a clear understanding of what is happening. Okay, so that was the first one. Let's move on to the next one. The next question is saying the locus of points 5 centimeters from C. Okay, this one is basically a circle with radius 5 centimeters from point C. So we go to point C and you draw a circle of 5 centimeters there. Okay, so let's draw the circle. Drawing the circle is going to be something like this. Okay, so the radius here should be a 5 centimeter. Okay, let's go on. The other question. A point R in a triangle. A point R in a triangle that is nearer B than C and is less than 5 centimeters from C, then show by shading the region. So basically here we want to shade. Let's go and see where we have that point there. Okay, so a point R which is going to be nearer to BC, so basically if we shade, this is going to be the area here. Okay, This is the area there. Okay, so this is where our R is going to lie. Now let's go to the next question. Measure and write down the size of triangle of angle ABC. ABC. So we want to measure this angle here, ABC. So if you measure it correctly, you should get a 96 degrees there. Okay, 95, 96, 97, somewhere there. Then the last one. Oh, that was the last one. Okay, fine. So let's move on to the next question. The next question is saying, show that this expression reduces to that. So let's do that. We cross multiply, and when we cross multiply, it's going to be, we are cross multiplying here like that. We are going to get 3x multiplying x minus 3 is equal to a 5. Okay. And we multiply, removing the brackets, we get 3x squared minus 9x is equal to a 5. We take the 5 this side, we get 3x squared minus 9x minus 5 is equal to a 0. We have shown that it's now equal to that. Let's move on to the next equation. Solve the equation. So we are now solving. So normally these questions, they like follow each other. So let's see how we solve this one. And the moment that they say to 2 decimal places, there are no two ways about it. Don't crack your head by trying to find factors. Just use your quadratic formula. So our formula says x is equal to minus b plus or minus square root of b squared minus 4ac over a 2a. Okay, so which one is our a? This is our a, this is our b, this is our c. Okay, so when we have this like that, our b is negative here, and here we also have a negative, so it's going to be a plus. Okay, so we can write x is equal to a 9 now, plus or minus square root of 9 squared, that's 81, because it's minus times minus, you get a positive, minus 4 by a is 3 by c is minus 5 over a 2 by a, which is 3. Okay, so when we do this, we'll get x is equal to 9 plus or minus square root of 4 times 3 times minus 5, we get, so we're going to get 81 plus 60 here over a 6. Okay, so this is going to be equal to 81 plus 60, that will be square root of 141. Okay, like that. So we now have 9 plus or minus square root of 141 over 6 is equal to our x. Okay, let's find the square root of 41 there. And you can even simply punch into the calculator, and we are saying our x value is equal to 9 plus square root of 141 over 6, or 9 minus square root of 141 over a 6 there. So you get your x value as, for the first one, we've got 3 point, sorry, that's a 9 point there. Let me just confirm. Okay, we have got square root of 9, square root of 41 there, 141. Let me just confirm. Square root of 141, that's 11.8, plus 9, that's 20.8, divided by 6, I'm getting a 3.48 there. Then all here, I'm getting a minus 0.479. Okay. So they said our answer should be in 2 decimal places. So we must have 2 decimal places. Here 3. So the answer is going to be 3.48 or minus 0.48 again. Okay, like that. So that's how we answer that one. Let's move on to the next question. Okay, here let me just zoom in and we try to find the angles there that we have. Okay. So we have here a diameter passing through center there like that. So this one is a 90 degrees. Okay, angle subtended by the diameter there. So here we can say it's 90 degrees. Then we can also calculate this one using the idea of triangles, and we can say 180 minus 90 minus 40, we get a 50 here. So this is a 50 degrees here. Okay, then I can use again the idea of a straight line here. Okay, so angles on a straight line, they add up to 180, so it's going to be also 180 minus 70 minus 50 here. So I'll get here a 60. Okay, and this is also a 90 degrees here, angle subtended by the diameter, this one. Okay, then the last one, it's also idea of the triangle, 180 minus 90 minus 60 there. I will get myself a 30 degrees here. Okay, so that's how we fill up the circle geometry there. Then once you are done, you can now answer the question. It becomes easier when you do it like this. Let's see. The first question, they are saying find BCD. BCD, let's see, BCD. So it's 90 degrees there. So we can say 90 degrees, and you can say angles subtended by the diameter. Okay, that will be your reason. Then the next one, ABD. ABD. That's a 60 degrees. We used the idea of angles on a straight line there. So we can say it's 60 degrees. And we said angles on a straight line, they add up to 180 degrees. Okay. Then the last one, ADO. Let's see our ADO. Okay, ADO. That will be here. AD and then O. That's a 30 degrees. We use the idea of the triangle there, and we say angles in a triangle, they add up to 180. Okay, let's move on to the other one. Oh, that was the last one. So let's go to we are now on section B, guys. Okay, so I think we have our 52 marks. Now here they are saying answer any 4 questions. We are going to do all of them so that you can select from those. Okay, so let's do this one. I think there are just some adjustments before we do this question. There was some typo error because you find out they are talking about a point N, which we do not see. There is a P there. So this P there is an N. Okay, that's number 1. Another typo which we have, I think that's the other one is the first question. Normally when they give us OB and OA like that, they'll ask us AB. So the first question there is going to be AB. Okay, I think the rest they are okay. So let's answer this question. It is given the diagram ABO is a triangle in which M is the midpoint of OB and N lies on AB such that AN, you see, that's why I was saying there was no P. AN is equal to 1 over 5AB. On ON and AM intersect at X. ON, okay, intersect at X. You see now, that's where our N comes from. Then we are given OA is A and our OB is B. So the first question, find in terms of A and B, AB. So we are simply saying, how do we get AB? AB is this one. So you are moving from A to B. You can use this route, A to O, then O to B. So we can say it's A to O, then plus O to B like that. Okay. So when we do that, remember we're given OA, but we are now saying OAO. So we are opposing the direction of the vector that we're given A. So it is going to be a negative. So we can say this is going to be negative A plus our B. Okay, that's how we find the vector there. Let's move on to the next question. So normally these questions, they just follow each other. We are now looking for AN. We are given AN is equal to, you see now, AN is equal to 1 over 5AB. That's why I was saying there was a typo error on our Zimsec paper. So it's going to be equal to AN is equal to 1 over 5 AB. The AB that we have just calculated here. So we simply multiply here and say 1 over 5 by our minus A plus our B. If you want, you can leave it like that. If you want, you can remove the bracket and it will be 1 over 5 minus 1 over 5A plus 1 over 5B like that. This will be your AN. Okay, let's move on to the next. I'm writing these guys. These things are very important. They show that it is a vector. So don't leave them out. Okay, let's move on. The next question is asking us ON. Let's see ON. O to N. What do we have? We have OA, okay? And we now have AN, the one that we have just calculated, 1 over 5 of AB there. So we can use that root, and it's going to be, let's write it down. Our ON is equal to OA plus AN. Like that. Our OA is A plus our AN, we have just written down, and it said it's equal to minus 1 over 5A plus 1 over 5B. Okay, like that. I can remove the brackets and have the A's together here. These are common vectors there. So we can have now, I can have, this is going to be equal to 1. This 1A here minus 1 over 5A, then plus 1 over 5B. Okay, so here I can have a common factor of A out, so I can say this is going to be equal to 1 minus 1 over 5. Okay, so I can simply subtract these ones. 1 is simply 5 over 5. This is 5 over 5 here. Okay, so I can subtract 5 over 5 minus, we get a 4 over 5A plus a 1 over 5B there. This is our final answer there. Then we are asking to calculate AM. Let's go to our diagram and see AM. This is AM. Okay, so AM, to get our AM, we can say we are moving AO and then OM like that. So OM is basically going to be half of OB. Okay, so that's how we are going to calculate that one. Let's calculate it. Our AM is going to be equal to AO plus OM. Okay, so it's going to be minus A, because we are opposing the A there, plus half of OB. Half of OB, it's a B, so it's going to be equal to minus A plus half B. Okay, so this is our final answer there. Then the other question is now saying, let's find, okay, we are given AX is equals to HAM. We calculated AM, we just calculated AM here at the top here, this one. So we can say our AX is equal to H, and then our AM is that one, minus A plus half B there. Okay, so we want to show it is equal to that. Okay, so I can remove the brackets and I'll have here minus HA and plus half HB like that. Okay, like that. Okay, that is AX. Now let's look at how we can get OX. OX, where is our OX? Let's see our OX. This is our OX. How do we go to OX? Using AX. We are using AX there. Okay, so we can get to OX using OA plus AX. So we are simply saying our OX is equal to OA plus AX. When we substitute, we get our A plus AX. We got our AX as minus HA plus half HB. Okay, so we have to simplify and take the A's together. So it is going to be A minus HA, then plus half HB. So these ones have a common A there, so we can say 1 minus H, and we have an A outside, plus half HB, like that. So you find out this is the expression that they were asking us. Okay, let's just confirm. Yes, this is the same expression there. So we can rewrite it here and say or we can just leave it. We can just leave it because it's here. Because normally this question they lead from one to another, so we will use it again. We are also given, so we said our OX is equal to 1 minus HA plus half HB, like that. Okay, so they are also saying OX is equals to KON. OX is equals to KON. Okay, so when we have such a question, our ON, how do we get our ON? Let's see our ON. Did we calculate ON before? Yes, we calculated ON here. So it is going to be half of K, that value there. So let's just write it. Our OX is equal to K by 4 over 5A plus 1 over 5B, like that. So we're getting 4 over 5 KA plus 1 over 5 KB, like that. So this is another expression of our OX. Then from this question, they will ask you to find the value of K, of H and K. Okay, let's see. Yeah, you see, this is why I was saying they are going to ask us. This is the question here. Okay, so let's use this from this point here. What we normally do is this. We say when the vectors, since it's the same vector, OX, this one and this one, they are equal. It means the value of A vector there, this one, is going to be the same as the value of A here. Then the value of B vector is going to be the same as B there. So with that information, we can form two equations. For A, we have 1 minus H is equal to 4 over 5K. Then for B, we are saying for B, it's going to be 1 over 2H is equal to 1 over 5K, like that. And I can make K the subject of formula here if I want here. Let's make K, I'm multiplying by 5 over 1 here, by 5 over 1 here. So that this side they cancel and I'll get my K. Then this other side, I'm going to have 5 over 2H. So I can substitute this one into this one, here. Let's substitute. Substituting, I'll get 1 minus H is equals to 4 over 5. My K, I said is times 5 over 2H. Okay, so they can cancel off each other. 5 and 5, 2 here, 2. So I have 1 minus H is equals to 2H. Okay, simplifying this one, I'll get 1 minus H there. I can take this H this side. So I'll have 1 is equals to 3H. Okay, so dividing by 3 both sides, by 3, they cancel. Our H value is equals to 1 over 3, like that. Then we go back with our H value on this expression. Okay, so we can say our expression was K is equal to 5 over 2H. So it is going to be K is equals to 5 over 2 by 1 over 3, like that. Okay, so our answer is 5 times 1, that's a 5, over 2 times 3, that's a 6. So our K value is 5 over 6. Okay, let's move on to the next question. Hence or otherwise. Okay. Find the ratio of the triangles OX. So basically we are looking for OAX over OAM, like that. Okay, let's see. I'm going to use the formula. Let's see. Let's just go to our triangle first and see. Let me rub off this part here. Oh, now I'm rubbing my end. Okay. Because I want to see what is common on them. This is our N here. What is common on these two triangles? So we have triangle OA, OAX, OAX, like this one. And we have another triangle OAM. So these are the two triangles. So you find out they've got a common angle there, which is that one there. Okay. So with this information, I can say, using my formula for triangle, half AB sine theta, I can say for triangle OAX, for triangle OAX, I can say this is equal to half. My A is my OA, here. This one, that will be my A. This is going to be OA, magnitude of OA, times B. I'll say it is my AX. This one. Okay, so I can multiply by AX there. Then my sine theta. Okay, so my theta, I'm saying, is the same common theta there. Then for my OAM, it's going to be half by OAX, which is common, this one, OA, and then multiplied by AM, this one, going there, because I'm taking this angle theta there, so it's going to be by AM, like that, by sine theta. So let's go and simplify this on our page there. So we are saying this is equal to half OA, magnitude of OA, times magnitude of AX, times sine theta there, which is our angle, over half OA, magnitude there, times our AM, magnitude there, times our sine theta there. Okay, so you find out we have got some common terms. This one will cancel off each other with this one with this one, sine and sine. So at the end of the day, our ratio of our triangle, area of our triangle OAX over triangle OAM there, is equal to magnitude of AM over, this is AX here, I'm writing M instead of X. X here over AM. Okay, like that. Okay, then if you remember, when we were calculating, we calculated once AX there, and we said our AX was equal to H, this part here. Our AX is equal to HAM, so I can use this. I'm going to use this information and say for AX is equal to HAM there over AM. Okay, so this and this will cancel. So it means our ratio of the triangle is equal to H. What is the value of our H? We calculated our H and we said it is equal to 1/3. So the ratio is 1:, our ratio is 1:3 there. Okay, that's how we do it. Let's move on. I was calculating on the wrong position. This is where I was supposed to answer there. We said our ratio is 1:3. I was like thinking this question is going further again. Okay. So let's see. Oh, we are now on number 7. Number 7 is saying that we are going to use this scale here to draw. Okay, so let's see. Triangle PQ has vertices. Okay, fine. So the first thing is to know the grid. We are using 2 centimeters to 1. So it's going to be 1, 1, 1, 1, 1, 1 for all axes. Okay, let me try to reduce this so that I can fit it here. Something like that. Okay, so I can take, let me see. Let me just put it up to here. This is my X value. My X-axis here. Oh, it's not coming out straight. This is my X-axis. And then my Y-axis, I can also take it at the center then. Let me take it at the center. This is my Y-axis here. Okay. This is my y-axis. Okay, like that. Then labeling, we say this is -1, -2, -3, -4, 1, 2, 3, 4, 5, like that. -1, -2, -3, -4, -5, -6, -7 if I want. 1, 2, 3, 4, 5, like that. Okay, fine. Now let's draw the triangle. Okay, so you find out the first triangle was saying it's P1, 1 and 3. Okay, let's draw it. 1 and 3, 1 and 3, 1 and 3. So that's our P here. This is our P. Then we have got our Q is 2 and 1. So our Q is here, 2 and 1. Then our R is 4 and 3. So it's 4 and 3 here. Okay, that's our R there. Let me properly draw this one. Point here, that's our R, not Q, R there. Then we join these together. Okay. So this is our triangle, guys. This is our triangle there. Okay. We have labeled it PQR. Now let's go to the next question. The next question is saying that we have got a reflection in the y is equals to minus the y is equals to minus x. So basically when we have y is equals to minus x, you can have a table. A table will help you to answer such question, like you say when your x is 0, what is your value of y? Okay, let me show you what I say. We can say this is going to be our xy values there, and I can say 0 and 0 here. So when my x is 0, what is my y? My y is equal to a, okay, let me use a different number here. Let me use a different number because I'm seeing that I'm getting a same number there. So when my x is 1, my y is -1, okay? When my x is 0, my y is 0. So it's passing through 0, 0 there, like that. So let's find the line. Let's draw the line. Okay, drawing the line, we said it's passing through point 0, 0. And also when our x is 1, our y is -1. So it is passing through like that. And also its y is equals to minus x. Gradient is minus. So when a gradient is minus, the lines are like this. When the gradient is positive, like y is equals to x, the graph is like that. Okay, so you must always remember that. Okay, so let's draw our line. So our line is going to be, I hope I'll draw it straight, passing through the points there. There it was. Okay, let's see this side. Okay, almost. So this is our y is equal to minus x. That's the question. Then the other part is now saying draw and label P1. So we are transporting, or we are reflecting PQR using that line. So when you are reflecting, the easiest way is to use a ruler. You draw a line straight passing through that point there. Okay, so this was not that straight, like that, from Q to Q there. Then you can have another one straight passing through these points like that. Okay, something like that. It's not coming out straight there because of my hand there. Okay, then you can also do the same for the R there. Okay, so you measure the boxes from P to the mirror line. I've got 1, 2 boxes. I'll also count 2 boxes, 1, 2. So it is going to be P here. Okay, you see. Then I go to my Q. It's 1.5. So I'm going to also count half in the 1. So it is going to be here, Q. Then my R, automatically I can get my R even if I don't use that one. It is going to be on the point -4, -3, this one. Okay, because it's also coming from there. Okay, like that. Then this is my R. image. So drawing our triangle there, we have our triangle like this. This is our triangle there, like that. Okay, let's move on to the next question. The next question is asking us to a transformation G maps triangle PQ onto that one with those vertices. So basically, let's draw label the P2, Q2 there with those vertices. So we are having here P is now on, let me draw it. P is now on 1 minus 6. So this is our P2 here, 1 minus 6. Q is now on 2 minus 2. 2 minus 2, this one. 2 minus 2. So this is my Q2. Then R is now on 4. 4 minus 6 there. Okay, like that. So this is my R2 like that. So the triangle will look like this. Okay. This is the triangle. Let's go to the question. What is it requiring us? We have drawn. Then they are saying describe fully the single transformation there. Okay, for the single transformation, let's see the diagram. If you look at the diagram, you will find out that my P is still on the same line there. My Q is on the same line there. My R is also on the same line there. So what it basically means is that our x-axis is invariant. It is not changing. The values that are changing are the y values is from there to here. Okay, so that's one thing there. So basically when we have such a transformation, we can say the transformation is, this is going to be our stretch. Okay, this is our stretch, so we can say it's stretch. Okay, that's number one. Then what is our stretch factor? Okay, before I talk about stretch factor, let's talk about invariant line. We said our x-axis is our invariant line. Then the last one is the stretch factor, which is k is equal to. So when you are finding the stretch factor, you can say, since we said our x-axis is invariant line, you can measure the image of OP from this point to this point over the original image from this point to this point. Okay, so you can see from this, for the image is going to be moving minus 6. For the object is 3, so it's going to be minus 6 over 3. So our stretch factor is a 2 minus 2 there. Okay, you can even confirm with the next one, which is Q, minus 2 there over a 1. So you get your stretch factor as a minus 2. So that's how you answer that part of the question. Then the last one is saying the point there, R3, is this one, and is going through an R, which is a translation. Then they want us to find the translation vector. Okay, so there are so many ways of doing this. You can say we have got our point there. I can say my point, which is minus 1, 2. I'm writing in the form of x, y. Then I say minus the original point of R, which was given as 4, 2. So I can have 4, 2 here. Then I subtract, I will get myself a minus 1 minus 4, we get a minus 5, 2 minus, we get a 0. So this is the translation vector, vector here, this one. That's what, where you are saying the image minus the original. Okay, so you are simply saying the image minus the original, you get your translation vector R there. Another way of doing it, I will come to my diagram. I will mark myself R3. R3 is minus, my R3 is minus 1 and 2. Okay, minus 1 and 2 there. The point R3 is minus 1. Let me just confirm something. R3 is minus 1 and 3 should be 3 there. Okay, it's 2 or 3. Minus 1 is here. Then I go to 3, so it's this one. Okay, fine. So this is my point R3 there. So I can say this is R3. Okay, so to get the translation vector, I want to see how I move from R1 to R3 there. You find out I'll go minus 1 there, and I'm going 1, 2, 3, 4, 5. Okay, so we are getting ourselves here we are getting for x minus 1, and then for y, for x is minus 5, for y it's a minus 1 there. So this is the translational vector. I'm wondering why is it different from this one. The original was a 4 and a 2. Oh, now I see. Now I see. Now I see. Now I see. Oh, now I see. This point here, guys, was at 3 here. So R was here. R was here. This was R there, like that. Okay. So that was an error there from the beginning. Okay, that was an error from the beginning. Because you must get the same translational vector there. So our 0 there. So we are just moving from R1, straight line there, minus 5. Okay, then let's see the next question. The next question is asking us to draw the, write down the coordinates P3, write down the coordinates P3 and Q3. So the easiest way is to just draw them or to just translate them on the diagram. Our Q, we move minus 1, minus 2, minus 3, minus 4, minus 5. So it's going to be here Q3. Which coordinate? Coordinate of Q3 is equal to minus 3 and a 1. Then for our P, minus 1, minus 2, minus 3, minus 4, minus 5. So it's going to be here P3. So P3 is equal to minus 4 and a 3 there. So these are the coordinates there. Okay, so we are done with that question. That's how we do it. Okay. Please take note of the corrections that we have just highlighted there. Now let's move on to question number 8. Okay, so please just avoid making such silly mistakes. They will cost you marks in the exam. Here we want to find the value of m. Okay, and the value of okay, we just wanted the value of m. Normally they will give you 2. Okay, so we use the equation, this one, and then we substitute with x is minus 1. So we are saying y is equal to x cubed minus 3x squared. We substitute to get our m. So we are saying our m is equal to minus 1 cubed minus 3 by minus 1 squared. So we get our m is minus 1 is cubed is just minus 1 times minus 1 times minus 1. This will give a positive, then you have times minus 1. So you get a minus. So it is going to be minus 1. Minus, then the minus 1 times minus 1, there we get a plus. Then times 3, we get a 3 there. So we get our m as minus a 4. Okay, that's the value of our m there. Now let's go and answer the, okay, they want us to draw the graph there. Please take note of the scale that they are giving us. For the x-axis, 2 centimeter is one box there. Okay. Then for the y-axis is 2 centimeter to 5 units. So it could be like 5, 10, 15, 20. Okay. So let's draw that. Okay. So the other thing, let's check our values. They are going to 20 for y. Okay, that's y. I see now. So let me just reduce this. Okay, so I can take it at the center. This is my x-axis. and then my y-axis is going from -2 to 4, so I can take it further from, let me just take it here like that. So this is my y-axis. Remember I said it's -1, -2, -3 there. 1, 2, 3, 4, 5, 6. Okay, then for x-axis we say -5, -10, -15, -20 there. 5, 10, 15, 20, 25 there. I can go there. Okay, fine. We have the scale. I forgot to write y-axis here. Y-axis. Okay, like that. Now let's plot the graph using the points that we are given there. Okay, so basically when it's cubed like that, you have to go up and down like that. Okay, so let's go and see how it is going to appear. Okay, let's take note of the points, guys. Let's take note of the points here. Okay, so the first point we've got -2 and -20. Okay, I've got -2 and -20, so I have this point here. Then the next one, -1 and -4, so it's at the center here. Then I've got 0, 0, okay, here. Then I've got, I should have used a different color here. Let me just change the color so that it makes sense. You can see the points. Okay, then we have got from 0, 0, we have got 1 and -2. 1 and -2. -2 will be close to 1 here, like that. And then we have got 2 and -4, so it's just below here, like that. Then we have got 3 and 0. Okay, it's coming back here. Then we have 4 and 16. Okay, 4 and 16, 4 and 16, 15 there. Then 16 is just 2 boxes up there, like that. Okay, so we are finished. So drawing, I'll have this point coming up like that. Okay, the last part is going to be like that. Okay, so we can label this is y is equals to x cubed minus 3x squared. Okay, so we have done the first part of the question. Let's see, that was 4 marks. Now they're saying use the graph to find an estimate, the gradient of the curve at the point x is equals to 3. Okay, so you want the gradient of the curve at the point x is equals to 3. Let's go to x is equals to 3. X is equals to 3. So this is the point, guys. X is equals to 3. This one. Okay. So you draw a line and open your ruler such that the gap that you leave here and the gap that you leave there is equal. Okay. So let me just try to do that. I think that was okay. Let me see. This one is below. Something like that. Okay, let me just extend there. Okay, then when you have such a question, you must always take extreme values. So I can take extreme values like, let me take which point? I can take this one. I'm going to take this one here. It's not coming out nice here. And then I want to take to, I can even take it to this point here. Okay, like that. Okay, so the points that I have are, for this one, I've got 5 and 12 here. Okay, then for this point here, I've got 1 and this is 2, 4, 6 and minus 13 there, minus 13. Okay, like that. Then our gradient is going to be change in y over change in x. Okay. So it is going to be equal to, from y, we are moving from minus 13 there over 5 minus 1. So we get here 12 plus a 13 over a 4. So the gradient is going to be like 12 plus a 13, that's a 25. 25 divided by 4, we are getting 6.25. So this is the gradient there. Okay, Let's move on to the next question. Area bounded by the curve y is equals to x-axis and the line y is equals to minus 12. Let's go and see this point there. Area bounded by the curve. Let me just use a different color here. Y-axis, so our y-axis is this one, and y is equal to minus 12. Y is equal to minus 12 is just here. Minus 12 is there. That's minus 11. 4 boxes down. Let me just confirm 4 boxes down there. 4 boxes down. 4 boxes down. That's 1, 2, 4. Here. This is minus 12. Okay, so the area bounded by this line, that is going like this. Okay. So you find out this is the area, guys, that we are looking for. So let's see the boxes that we have there. I've got one full box, this one. I've got almost like here, another one here. So this I'm done. And I've got this small portion here. I can add it to this portion and say I now have 2 boxes. And then I have this one. I've got this one and this one. If I add them together, approximately the number of boxes that I have here and there, they can give me like, it's not a half, it's more than a half. It's not 2 over 3. So I can say it's like 3 over 5. Let's take 3 over 5. So I have 2. So I can say the area is going to be equal to 2 and 3 over 5 square units. Okay. So these are the square units there. This is the area approximately. Then the last one is saying write down from the graph the range of values of x when the curve has a negative gradient. Write down from the graph the range of values of x when we have a negative gradient. Okay, so let's go to our graph there. Okay, let's go to our graph, negative gradient. So our negative gradient, remember when we have a negative gradient, we said this going that direction, that's a negative gradient. Okay, so for us now, the range of values of x when the curve has a negative gradient. Okay, so the negative gradient, we are getting it here. Okay, this is where we are getting the negative gradient. We don't have any other point because this side is positive, this side is positive, this side is positive. Okay, so the set of value when we have our gradient is negative, we are saying our x values are 2, 1, and 0 there. Okay, so those are the values there of x's when we have a negative gradient. We are saying 0, 1, and 2. Then the last part of the question, use the graph to solve the equation x cubed. So basically this is y is equals to this and y is equals to x to 2. So when we have such a question, what we do is we simply draw a line of y is equals to 2 there, and then we find the value of the x's. So y is equals to 2. Y is equals to 2 is approximately, let me just zoom in. Y is equals to 2 is here. 1, 2, 4 here. Here. This is our y is equals to 2. Okay. So the value is just 1 here. We have this interpolation here. So I'm getting here. Let me just zoom in again. That will be like 3 and 3.3. Okay. So the value of x there is going to be 3.3. Okay. So that's going to be a 3.3 there. Our x is equal to 3.3. That's how we find the value there. Okay. Let's move on to number 9. Okay, number 9 is saying factorize completely. So you must factorize completely. So basically this is a perfect square. So I can say x minus 2 and x plus 2. This is the factorization. Then the next one, for the next one, I can try to find the number of factors that can go into this one and this one. Okay, fine. So I want a number that two numbers, when I add, I get minus 5x. When I multiply, I get 6x squared. You find that the number that I can think of are minus 3 and minus 2. So I'm rewrite this equation as x squared minus 3x minus 2x plus 6. So I can now take factors of this one and factors for that one. For the first one, I have a common factor of x and I get x minus 3 inside. For the second one, I've got minus 2 and I'll get minus x minus 3 there. So I've got factors of x minus 2 and x minus 3. Okay, so these are the factors there. Okay, let's go on to the next one. Okay, the next one is saying, hence, find the highest common factor of this first one, the first one that we had, and the second one, which was this one. Okay, so for the first one, we said the factors were x minus 2 and x plus 2. Then the second one was x minus 2 and x minus 3. So what it means basically when we say highest common factor, it is something that goes into this expression and also goes into this other expression. So you find out we have a common bracket here, x minus 2, here x minus 2. So the highest common factor is going to be x minus 2 like that. Let's go to the next one. Okay, fine. That was the last of it. If they had asked about lowest common multiple, you were just going to take everything and you have lowest common multiple as x minus 2. You are taking this and this, then you have x plus 2, this one, then you take the last one, x minus 3. That will be the lowest common, the term that all the terms can all go into. Okay, let's do the last one. Part B. S is equals to A over 1 minus, then we are given the values there. Okay, so let's substitute. We are saying S is equals to, our A is 81 over 1 minus 1 over 3. Okay, like that. So if I want, I can rewrite that this is 81 divided by 1 is 3 over 3 minus 1 over 3, like that. I just want to simplify my life. So I'll get here 81 divided by 2 over 3. So I'm just multiplying 81 times 3 over 2. I'm interchanging this. Okay, so 2 here, I multiply, I'll get 121.5 as the value of S. Okay, how you do it. Then they are saying make R the subject of formula. So we have S is equal to A over 1 minus R. You multiply every side by 1 minus R by 1 minus R there. This will cancel off each other. So we have S multiplying 1 minus R is equal to an A. We multiply everything inside the bracket there. So we have S minus SR there is equal to A. Because we want A, we can take this one, this side. We want R, isn't it? So we can take this side so that it is a positive, and this one I can take it this side. Okay. So I'll have at the end of the day, S minus A is equals to SR. Then we divide by S, divide by S, this side. S and S cancels each other. So our R value is going to be R is equals to S minus A over an S. That's the subject of formula there of R. Let's go to the next question. We are given that from a group of 30 people at a party, it is observed that 17 ate beef and 16 people ate pork. Okay, fine. Then they are saying X people ate both beef and pork and 6 people ate neither beef or pork. Then they're saying calculate the X value, X number of people who ate both beef and pork. So for me, it is easier to just draw a Venn diagram for this one. I have my beef, I have my pork. Beef, I have my pork. This is my universal set there. Let's write what we have. So we are told that out of 30 people, there are 30 there, 17 ate beef, and then 16 ate pork, okay? Then X ate both. So when they say X ate both, so I'm going to say here minus X here because they ate both, minus X there, okay? Then those who did not eat anything of those, there are 6, so you can have a 6 like that. So when we have this, I can have an expression of adding all this should be equal to a 30. So I can say 17 minus X, that's for beef only, plus those who eat beef and pork, plus those who only ate pork, 16 minus 6x, then plus a 6 is going to give me a 30, like that. So if I simplify, I'm going to get 17 plus 16, okay? Then I've got plus 6 there, plus 6 there. Then I've got minus x here, plus x, then minus x is going to be equal to 30, like that. Okay, then if I add these values there, I'm getting a 39. And here I get a minus x there. Minus x plus x, that's a 0, minus x, so I get a minus x there. Minus x is equals to a 30. Okay, so I take this one this side, it becomes a positive, that will be an x. This one this side, it becomes minus, so I have 39 minus 30. So my x value is equal to 39 minus 30, that's a 9. So our x value, those people who ate both beef and pork, are 9 people. Okay, so that's the last question there. Let's move on to number 10. And now let's go to question number 10. Okay, question number 10 is saying, in the diagram, KLNG is a trapezium in which LMN is a straight line, okay? And KLM is equal to K. Which angles are we talking about? KLM, KLM. Okay, they are 90 degrees. Okay, I see them. MK is 7 centimeters. And MG is 5, LM is equal to LMK is 60 degrees, and NMG is 35 degrees. Calculate the length of NG. Okay, NG. Okay, fine. So basically, we are looking for this length there, NG. And we have got this triangle like that. So let's use that triangle to calculate our NG. I'm going to redraw the triangle so that it is easy for us there. We've got 90 degrees, we've got 35 degrees here, and we've got 5 centimeters here, and we want our NG here. Okay, I'll leave the rest here with M. So you find out to get NG, I can use sine rule, NG over sine 35 degrees is equal to 5 over sine 90 degrees. Okay, and always remember sine 90 degrees is equal to 1. So this is equal to a 1, this one. So I'll have my NG is equal to 5 times sine 35 degrees. And you find out I have 5 times sine 35 degrees, that's 0.5736 there. And we get our NG as 2.867. So you write your NG to 2 decimal place, 2.87 centimeters. Okay, let's move on to the next question. The size of KMG. KMG, where is our KMG? Okay, the size of KMG. KMG. So we want this angle here, this angle. Remember that is a straight line there. So angle on a straight line, they add up to 180. So we are going to say 180 degrees minus 60 degrees minus 35 degrees is equal to angle M there. Okay. So when you subtract there, you get your angle M as 85 degrees there. Okay. So that's our angle of KMG. Let's move on to the next question. So we said here it's 85 degrees. The next question is saying calculate the area KMG. So we are basically using that triangle there. We are using this triangle KMG, this one. And it has got sides 7 and 5. So let me just redraw it there. I have this 7 centimeter here. This is my K, my G. This is my M. I have 5 centimeter here, and our angle is 85 degrees. So we are just going to use area of a triangle is half AB sine M degrees there. M sine M. Okay. So this is going to be equal to half A, that's a 7, times our B, that's a 5, times sine 85 degrees. So if you do that, we are going to get for this part, if I multiply, I'm getting 17.5 times sine 85 degrees is close to 1, so it's 0.99619. And we multiply, I'm getting 17.4 centimeters squared. That's the area there. Okay, let's move on to the next question. Length of kg. Okay, so now we want this length here, kg. So to get length of kg, basically, I can use the cosine rule. Let's just use the cosine rule and say kg squared is equal to 7 squared plus 5 squared. These are my ABCs there. Minus 2 by 7 times 5. Then we say cos 85 degrees. Okay, so our kg squared is equals to here 49 plus 25 minus here I've got a 70 here, then cos 85 degrees I'm getting here 0.0871. Let me just confirm cos 85. Let me just confirm quickly. Cos 85. Okay, that's correct. So at the end of the day, I've got my kg squared is equals to 74 here, 49 plus 25, then minus 6.1009. So at the end of the day, I'm getting kg is square root of 74 minus 6. That's a 67.8992 there. Okay, I just don't want to round off things fast. That's why I'm writing this. So I get my kg, if I do that, is 8.24 centimeters. Okay, we are done. Let's move on to the next one. The size of mkg. mkg, let's go mkg. M, K, and the G there. Okay, that side there. Okay. So to get this side mkg, mkg, I want the angle there. Okay, fine. I can just use sine rule. I can just use sine rule because this side I now have kg is 8.24 here, and we want this angle there. And then I can say this one. Okay, yes, we can say sine k over 5 is equal to sine 85 degrees over 8.2 there, 8.24 there. Okay, yes, like that. Then I'll have my sine k is equal to sine 5 times sine 85 degrees over 8.24. Okay, so let's finish it down there. So it's going to be equal to our sine k is going to be equal to 5 times sine 85 we just calculated earlier when we said it's 0.9961 over 8.24 there. Okay, so if you calculate, you get sine k is equal to 0.0 0.6, sorry, 0.60448. But this is not K. This is sine, like sine theta. So you want to find the angle K. So to get K is going to be arc sine of 0.60448 there. When you do that, you get your K as 37.2 degrees. Okay, let's move on. Oh, we are done. Number 11 is saying a group of youths wishes to make, they wish to make and paint chairs and tables for sale. Let X be the number of chairs and Y be the number of tables to be produced. Okay, the group wishes to produce at least 5 chairs and not less than 5 tables. Okay, fine. Then they are saying write down the inequality. So for this one, for the chairs, I can say they are saying at least, so they want 5 and more than. So I can say it's going to be chair, it's X, isn't it? X is greater or equal to 5. Then for the table, they are saying not less than. So we want more than. So it's going to be Y is greater than 5. So these are the two inequalities for that one. Then the other one, the group has 48 hours to make the chairs. So they are saying it takes 4 hours to make a chair and 3 hours to make a table. So remember our table in X, our table is Y, our chair is X. Okay, so we can say, when we have such an information, we can say 4 for the chairs, that's X, plus 3 by the chairs is going to be, because we want to say the group has 48 hours to make. They have to make either by 48 hours or below 48 hours, not more than. So we can say less or equal to 48 hours there, like that. Okay, then let's go on to the next one. The group hired a compressor for 14 hours. Okay, then the chairs and the tables, so they are using the same information there for the chairs and the tables there. Given that it takes 1 hour to paint a chair and 1 hour to paint a table, we want to form an equation that satisfies that they are going to have such X chairs and Y tables. So we can say 1 hour times X chairs plus 1 hour times Y chairs is going to be less or equal to, again, 14, because we have a condition there of using for 14 hours. We can't exceed, but we can go to 14 hours exactly. So our equation is basically equal to X plus Y is less or equal to 14, like that. So we have formed the equation. Now, okay, now it's asking us to draw these graphs, these inequalities on the graph. And we are given that we are to use the ratio, the scale as 2 centimeters to 2 units, okay, for all x's there. So it's going to be 2, 2, 2, 2, 2, 2, 2, 2. Let's see how we can draw this one, okay. What is the highest value we have for x? For x, the highest value we have is 5. For y, we go is, okay, fine. Okay, fine. We can work with this one. We don't have much values below the x-axis, so I'm going to take it. I'm going to take it from here. Let me see. I'm going to take it as a positive there. So we are saying 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, fine. Let me just take it, my x-axis there, because I don't think we have got values that are below 0 there. So this is my x-axis. Then my y-axis, my x-axis are more positive again. So I can as well take it. Let me just take it at this box here. I'm not really sure. Let me just take here. Oh, it's going down. So this is my y-axis here. Okay. Then we said each boxes, they are going to be like what? 2, 2, 2, 2. So it's going to be like -2 here. Let me write -2 here for x, -2 here. In case we have some minus there, -4 here. Then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 here. Okay. And for x-axis is the same, 2, 4, 6, 8, 10, 12, 14, 16, 18, like that. Okay, fine. Now let's draw the graphs. Okay, so you find out for the first one we had x is greater than 5. So when it is like this, it's bold like that. When it is like this, it's dotted, it's broken. Okay, so let's draw this one. So we have the first one, x is greater or equal to 5. So we go to our x is greater or equal to 5. So my 5 is here. For my x, my 5 is at the center there. And we said it's a straight line, so it's going to be straight like this. It's not coming out at the centers. Let me just confirm. Okay, something like that. So this is y, this is x is greater or equal to 5. Okay, then we have y is greater than 5. So we go to y is greater than 5 at the center there again. So this is my y is greater than a 5. Oh, it's broken, so I can break this one. Let me just do the broken part. The broken part. It's not rubbing everything. Here, here, and here, and here. Okay, so that's that one. Let's move on to the other one. The other one was 4x. So for this one, I can do the x and y values there. When x is 0, what is my value for y? And when y is 0, like that. So when x is 0, y is 48 divided by 3, I get a 16 here. When y is 0, my x is 12 here. Okay, so I have those 2 points. Let's go and draw those 2 points there. Let me just extend this straight like that. Okay, fine. Then we are having 2 points. Let me just mark the points now. Let me use a different color. We have 0, x is 0 and 16. That's this point here. Then we have y is 0 and 12. So it's these 2 points here. Okay, fine. And it's going to be a straight line. It's bold because it is not broken. Okay, something like that. So this is my y, my 4x plus 3y is less or equal to a 48. Okay, let's go to the next one. Let's go to the next one. The next one is saying x plus y is less than or equal to 14. So we can do again the x and y zeros there. 0, when also that one is 0. So when x is 0, y is 14. When y is 0, x is 14 there. Okay, so those are the points that we have. Let's draw this one. Okay, so I've got x is 0, 14, so I've got 14 here and 14 here. Okay, fine. Is it making sense here? Let's see. So it's going to be like that. Okay, so this is my y, my x, sorry, this is my x plus y is less or equal to 14. So we have drawn everything there. Okay, now let's see. The question is basically going to ask us to solve the question there. Let's go. Where's the other question? We have drawn there. Okay, now they're asking us the profit. That's the last part of the question. Okay, The profit on a chair is $10 and the profit on a table is $20. Okay, so use the graph to find the greatest possible profit that can be made. So we want to make sure that we get more of tables which have got 20 and more of and less of but we want even more. Okay, so we are here, guys. We are here. Remember, this is broken, so we can't take numbers that are there. So the numbers that we are going to take, we want more of the tables, so we can take this point here, that point there, we can take it, which is like we said it's 2 4, so it's like 2 4 5 midpoint of that one, that is a 9. So my tables are going to be 9. Then let's see, if I take 9, I'm going to take my x value, which is the chair, is going to be also in that line there, which is the center of 5 there. So if I take this one, I'm taking 5 and 9. So that's 1 point. Then another point which I have, which has got more of this one. Let's see. If I take this one, I've got less. Okay, I've got less here. I have got 8 tables and 5, it will be less. I've got 5 and 8. I wrote it wrongly here. I should write 5 and 8. Okay. Then another point that I can take of interest is this one, because I've got here 6 and 8. Okay. So basically, let's work with those numbers and see the values. We have got 5 and 8. We have got 5 and 9, and we have got 6 and 8 there, and see which one will give us the most value there. So if we take the first one there, 5 and 9, we are simply saying 5 times 20. 5 times 20, we get 100, plus 9 times 10, so we get for this one, we're getting 100 plus 90, that's 190 here, $190. Then for this one, 5 times 20, that's 100, plus 10 times, that's 180 here. Okay. Then this one, last one, we have got oh, I was multiplying wrongly here. Sorry. I was taking the chairs to be x here. Sorry for that. The chairs are the ones with the 10. So it's like here, I've got an 8 here. The chairs are $20. This is $20. This is 10. So it's 5 times 10, that's 50, plus 20 times 8, that's going to be 120, 160 plus 50. This is 210 here. Okay. Then for this one again, 10 and 20. So it's going to be 9 times 20, 180, plus 50. Plus 50, I get 230. So here I get 230 here. 10 again and 20 here. 20 times 8, that's 20 times 8, I get 160, plus 60. I'm getting 120 here. 220, sorry, 220. So basically, this is the highest there, you see. We can't take these values down here. These ones down here are not making sense because they are low. So basically, the combination we have is like 5 chairs and 9 tables. Okay, so that's the combination there. We can have 5 chairs and 9 tables. Then we make more profit there because the table have got more money. Let's go on to the next question. I hope this is the last one. Okay, so it's saying we have, yeah, that's the last one. The table below shows the heights, h, c, centimeter, and a group of 200 children. Find the value of p. Okay, so basically finding the value of p, we should always know that the formula for our frequency density is equal to frequency over class width, like that. So for my value of P here, I want to find my frequency density. So it's going to be equal to frequency, which is 45, over my class width, that's 80 minus 75 there, I get a 5. So it's going to be 45 divided by 5, I get a 9. Then when I do the same for Q, I've got my frequency is 40 here. Then divided by class width 100 minus 80, that's a 20. So I'm going to get a frequency density of 2. So those are the values there, okay, of P and Q. Now let's go on. So let's now go on to the next question. Calculate an estimate of the mean height of the children. So when we are looking for the mean height of the children, what we have to do first is to find the midpoint of each class from 50 to 60. So you'll be like saying 50 plus 60, then you divide by 2. What do you get? So you find out 50 plus 60 there divided by 2, I'm going to get 55. I do the same for this class. 70 plus 60 divided by 2, I get 65 here. I do the same for this one. 75 plus 70 divided by 2, I'm getting 72.5. The other one, I'm getting 77.5. Then the last one, I'm getting a 90. Now to get the mean, our mean is going to be equal to, you say now, the midpoint of the class times the frequency associated. So it will be 55 times 24 plus 65 times 38 plus 72.5 times 53 here, plus the next one, that's 77.5 times 45. Then lastly, plus 90 by 40. Or it's going to be divided by the total number of children, which is 200. So when you do that, you find out you get 55 times 24, that's 1,320, plus 65 times 38, 2,470, plus 72.5 times 53, I'm getting 3,842.5, plus 77.5 times 45, I'm getting 3,600 here, plus, okay, 1, 2, 3, 4. I left out the other one here. This one is for the last one. So the last other one is 77. I get 3,487.5 divided by 200. Okay. So if I do this, I'm getting 14,720 over 200. And I'm getting 73.6 as the mean. Okay, that's how we get the mean there. Okay. Then we now have to draw the histogram now. Let's draw the histogram. Drawing the histogram, we are basically considering two rows there. Okay. Let's consider the 2 rows. The rows that we are considering are these ones. The one with the height and the one with the frequencies there. Okay, so let's draw the graph now. Remember, our P is 9 and our Q is 2. Okay, so let's draw. I'm going to have my scale. Let me just draw. So this side I have my frequency density, and at the bottom I have my height. Okay. Now I'm going to have my frequency density. The highest is 10, so I can as well go from 0, 1, 2. Do we have a scale? Okay, they gave us a scale. For the height, that's the x-axis, is 2 centimeter to 10. Then for the other one, which is the frequency density, is 2, 2. Okay, 2, 4, 6, 8. Okay, so I can say here 0, 2, 4, 6, 8, 10, 12. Okay, I don't think we have got such numbers up there. Then for the bottom, we are moving from 10, 10, 10. Okay, so we are starting from 50. So I can as well have my 50 here if I want, such that I have this to show that there are some numbers down there. Okay, so let me just zoom in here. 50, 60, 70, 80, 90, 100, like that. Okay, like that. Now let's finish off and finalize. Our first one is coming from 50 to 60, and it has got a frequency density of 2.4. 2.4 is 4 boxes up, is one box up here. So it's on this line here. So this is our 50 to 60. Okay, 50 to 60. Then from 60 to 70, that's 3.8. 3.8, our 3 is here. 0.8, it will be just one box below that one. Then it goes to 70 like that. Then we have got 70 to 75. So 75 is in between here. That 75 is 10.6. 10.6, that's 3 boxes up there. So it's going to be like this. Then here it's going to be at the center there, going down like that. Then the other one is 9, 75 to 80 is 9. So at the center here, 9, and goes down. Okay, like that. Then from 80 to 100, that's a 2. So we are going like this. Okay, so that's our histogram, guys. This is our histogram there. Okay, we were trying to follow what they said, that 2 centimeters is representing 10 units. Okay, let's move on. The last question is saying 2 children are chosen at random. They are chosen at random from the group. Find the probability that each has a height which is greater than 75 centimeters. 75 centimeters. Let's go to our question. 75 centimeters. Okay, so it's going to be 45 plus 40 there. Okay. So what it means when we do this is like we are saying 45 plus 40. Those are the children that are 75 centimeters and above. So you find out total is 85. Out of the total number of students, that's 200. So it's going to be first student that we pick is going to be 85 over a 200 times, because we have picked one student, we are going to less one here and less one there, because we have picked a student. We no longer have 85 students. We now have 84 students. Total is now 199 because we have picked one student. So we now multiply this. When you multiply this, this is equal to 85 divided by 200, that's 0.425, times 84 divided by 199 is 0.422. So at the end of the day, we're getting 0.179. This is the probability of the 75 greater than there. Okay, so this was the last question, guys. So please remember to subscribe on our YouTube channel, Mobilemaths, and share with your colleagues. Please like our videos. Bye-bye.